Mastering Kubernetes Pods, in-depth guide to lifecycle and management. This podcast is brought to you by Business Compass LLC. We are an Amazon Web Services advanced consulting partner. We build and migrate workloads to Amazon Cloud. Our website is businesscompassllc.com. Our phone number is 973-638-2228. Our email address is contact@businesscompassllc.us. Introduction to Kubernetes Pods. Kubernetes, a powerful container orchestration platform, has revolutionized how we deploy, scale, and manage applications. At the heart of Kubernetes are pods, the most minor deployable units in a Kubernetes cluster. Understanding pods and their lifecycle is crucial for anyone looking to master Kubernetes. This podcast will take you through the intricacies of Kubernetes pods, their characteristics, lifecycle, and essential management techniques. Defining pods, the smallest deployable units in Kubernetes. In Kubernetes, a pod represents a single instance of a running process in your cluster. It can contain one or more containers with a unique role but sharing the same network namespace and storage. Unlike standalone containers, pods enable more accessible communication between containers, making them ideal for microservices architecture. Pod characteristics and components. Several vital components characterize pods. Containers, the primary workload units within a pod, typically Docker containers, that run your application processes. Namespaces provide isolation between different pods, ensuring that resources and names do not conflict. Shared volumes, persistent storage that can be shared between containers within a pod, enabling data sharing and consistency. Composition of pods, containers, namespaces, and shared volumes. A pod's composition allows containers to work together seamlessly. Containers in the same pod share the same network IP, port space, and storage, allowing them to communicate efficiently and share data. This setup is instrumental in microservices, where different containers may handle various aspects of an application but need to operate in tandem. Ephemeral nature of pods and unique IP address allocation. Pods in Kubernetes are designed to be ephemeral, meaning they can be created, destroyed, and replaced dynamically based on the application's needs. Each pod is assigned a unique IP address, which allows it to communicate within the cluster. However, this IP address is temporary and changes whenever a pod is restarted or recreated. Pod lifecycle explained. Understanding the pod lifecycle is essential for managing and troubleshooting your Kubernetes applications. A pod's lifecycle is defined by various phases that indicate its current state. Understanding the phases of pod lifecycle. Pending, the Kubernetes system has accepted the pod, but one or more containers still need to be created. This phase can occur due to insufficient resources or other scheduling issues. Running, the pod has been scheduled on a node, and all its containers have been created. At least one container is still running or is in the process of starting or restarting. Succeeded, all containers in the pod have terminated successfully, and the pod is no longer running. Failed, all containers in the pod have been terminated, and at least one container has been terminated in failure. Crash loop back off. A container in the pod has failed and is restarting repeatedly. Kubernetes will attempt to restart the container until it succeeds or the pod is terminated. Unknown. The state of the pod is unknown due to a lack of communication with the node where it was running. Terminating. The pod is in the process of shutting down. Kubernetes is stopping all containers and cleaning up associated resources. Evicted. The pod has been forcibly terminated due to resource constraints or node failures. Managing pod restart policies. Kubernetes provides various restart policies to manage the behavior of pods when their containers fail. Always. The container is restarted continuously until it succeeds. On failure, the container is restarted only if it fails. Never. The container is never restarted, regardless of its exit status. These policies allow administrators to control the availability and resilience of their applications. The role of the kubelet in managing pod lifecycles and restart policies. The kubelet is a critical component in Kubernetes that runs on each node in the cluster. It is responsible for ensuring that containers in a pod are running as expected according to the pod spec. The kubelet continuously monitors the pod state and takes action based on the defined restart policies. Creating pods in Kubernetes. Creating pods in Kubernetes can be done in two primary ways, imperatively and declaratively. Imperative versus declarative approaches, using kubectl run and YAML definitions. Imperative approach, using the kubectl run command, you can quickly create a pod with specific parameters. This method is suitable for quick testing and development. Example. Kubectl run jinx image equals genjinx. Declarative approach, using YAML definitions allows for more control and reusability. You can define pods in a YAML file and create them using the kubectl apply command. Example YAML. API version, v1. Kind, pod. Metadata, Name, nginx. Spec, containers. Name, nginx. Image, nginx. Command to apply. Kubectl apply fnginx pod.yaml. Exploring pod specifications with Kubectl explains. Kubernetes provides a powerful tool, Kubectl explain, which offers detailed insights into the fields and structure of Kubernetes resources. Utilizing Kubectl explain for detailed insights into pod specifications. To explore the specification of a pod, use the following command. Kubectl explain pod.spec. This command provides a breakdown of all the available fields and their descriptions, allowing you to understand better how to configure your pods. Essential Kubectl commands for pod operations. Kubernetes offers a range of Kubectl commands for managing pods, making it easier to handle day-to-day operations. Navigating pod management with Kubectl. List, describe, explain, exec, top, and delete commands. List pods. View all pods in a namespace. Kubectl get pods. Describe pod. Get detailed information about a specific pod. Kubectl describe pod name. Explain pod. Get detailed information about the pod specification. Kubectl explain pod. Exec into pod. Run a command in a container in a pod. Kubectl exec it pod name, /bin/bash. Top pod. View resource usage of a pod. Kubectl top pod name. Delete pod. Remove a pod from the cluster. Kubectl delete pod name. Summary and next steps in Kubernetes mastery. Recap of key concepts and next steps for deepening Kubernetes knowledge. Kubernetes pods are the foundation of your applications in a Kubernetes cluster. Understanding their lifecycle, characteristics, and management practices ensures your applications run smoothly and efficiently. With this deep dive into Kubernetes pods, you are well on your way to mastering Kubernetes. Next, consider exploring Kubernetes controllers, such as deployments and stateful sets, to further enhance your container orchestration skills. Thank you for listening to our podcast. Please share this podcast, visit our website and follow our social media links.